The next topic is Ohm's law. Ohm's law आपने 10th standard में कर लिया बेटा. I am again explaining you Ohm's law. Ohm's law is defined as the current flowing through a conductor is directly proportional to the potential difference applied across its ends. Means V proportional to I, but the conditions is temperature and other physical conditions remains unchanged. Here other physical conditions are pressure, volume, temperature. They should remain same. V proportional to I. On removing the proportionality sign, we will get V is equal to I into R. If we draw a graph between I and V or V and I, the graph between V and I is a straight line. Straight line graph shows that V proportional to I. There are two ways to represent the graphs. Number one is graph between V and I. Please take care about this. Which quantity is along y-axis, which quantity is along x-axis. If we take potential difference along y-axis, current along x-axis, then slope is equal to V upon I is equal to resistance. The slope of VI graph gives us the value of resistance. If IV graph is given to you, means I is along y-axis, V is along x-axis, then slope is equal to 1 by R. That is called conductance. Means slope of IV graph gives us the value of conductance. Is it clear to everyone? I am again repeating the point. The slope of VI graph is equal to resistance. The slope of IV graph is equal to conductance. And if angle this theta is given to you, then slope is given by tan theta. Now the next term is resistance. आपको पता है resistance के बारे में? Resistance is the property by virtue of which it opposes the flow of charges through it. Means resistance, in simple words, resistance is the opposition to the flow of current. Mathematically, its formula is R is equal to V upon I. R is resistance, V is potential difference, I is current. The SI unit of resistance is ohm. 1 ohm is equal to 1 volt upon 1 ampere. The definition of 1 ohm is the resistance is said to be 1 ohm if a current of 1 ampere flows through it on applying a potential difference of 1 volt. Means if we apply 1 volt across the ends of the conductor and the current of 1 ampere flows through it, then the resistance is 1 ohm. Next is factors affecting the resistance. At a constant temperature, please underline this point. At a constant temperature, resistance of a conductor depends upon number one, length. R directly proportional to length. More is the length of the conductor, more will be the resistance. Number two, resistance is inversely proportional to area. R inversely proportional to area. Means more is the area of cross section of the wire, lesser will be the resistance. Or you can say that thicker wire has less resistance than thin wire. Number three, nature of the material. Nature of material means suppose one material is copper wire, another is nichrome. Copper is a metal, it has low resistance. Nichrome is an alloy, it has high resistance. Means nature of the material. Wire is made up of which material? Third point, resistance depends upon nature of material. By combining all the factors, you will get R proportional to L upon A. Proportionality sign हटा दो. R is equal to rho into L upon A. This rho is called resistivity or specific resistance of the material. Underline these 3 lines. It depends upon the nature of the material of the conductor and on the physical conditions like temperature and pressure. Please remember this point. Resistivity does not depend upon size or shape. Resistivity is also known as specific resistance. If we consider L is equal to 1 unit, A is equal to 1 square unit, means L and A is equal to unit, then R is equal to rho. Underline this definition and learn this. Resistivity or specific resistance may be defined as resistance of a conductor having unit length and unit area of cross section. SI unit of resistivity is ohm meter. ये आप पहला कर चुके हैं. The next term is current density. Current density at any point is amount of charge flowing per second. Amount of charge flowing per second is current through a unit area held normal to the direction of flow of charge. This topic is very, very, very important. Current density at any point inside a conductor is defined as amount of charge flowing per second. Amount of charge flowing per second is current through a unit area, means upon area held normal to the direction of flow of charge. It is given by the symbol small j. J is equal to current per unit time, charge per unit time upon area. Charge per unit time is current I upon A. बच्चे आप एरिया वेक्टर बारे पहला चैप्टर 1 च कर चुके हैं. Area vector is always directed normal to the surface. Here are 2 examples. Number 1 is charge is flowing, the current is flowing perpendicular to the surface. Area vector is also acting perpendicular to the surface, means I and A both are in the same direction. In example 2, this surface makes an angle theta with the current. Area vector is here perpendicular to the surface, means A's area vector makes an angle theta with the current. Along current, the direction of area vector is A cos theta. Current density is defined as current per unit area that is held normal to the direction. Normal क्या है? A cos theta. Therefore, the other definition of I is equal to J A cos theta. It can be written as J dot A. You know that A dot B is equal to AB cos theta. Here I is equal to J A cos theta, that is equal to J dot A. Now, current is a scalar product of 2 vector quantities. Now, it is a scalar product of 2 vector quantities. Therefore, I is a scalar quantity. The SI unit of current density is, the SI unit of current is ampere. Area is meter square. The unit of current density is ampere per meter square. If a small part of the area is given to you, small part, then we integrate it. J dot ds, total area kaddali, integrate over the surface area. Now the next term is conductance. Conductance is defined as the reciprocal of resistance. Read these definition once. Conductance, the symbol of conductance is G. G is equal to 1 by R. R has unit ohm, therefore G has unit ohm minus 1 or mho. Next is conductivity. The reciprocal of the resistivity is called conductivity. Conductivity is equal to 1 upon resistivity. Thank you.